Okay, in this video we're graphing functions to find limits, and these are piecewise functions. So this is called part 2, and I already did part 1 for the more traditional type functions. Okay, basically in a piecewise function you should know what a piecewise function is. It's a graph that's in pieces. So I graphed this function, and we want to know what the limit of this whole function is together. And if you look at it, when we're coming from as we approach 0, so we're approaching 0 from the left and from the right. So we're going up here. We're approaching 0 on the x from here, and from the left from here we get 0. Okay. Alright, so the value of the function gets close to 0 as x gets close to 0. That's your n, so that's your number, and that equals 0. Okay, the next one's very similar. We always usually take the limits here of this value here. So I graph the function, and keep in mind on piecewise functions, this one right here is really an open circle here. But since this one is a closed circle overrides open circle. So you can see as we get closer and closer to 0 on the x, there's the x on the 0, from below and then from above, our limit as x approaches and gets closer to 0 is -1. That's our n. That's your y value. Okay? Now this one, let's look at this one. We're going to take the limit as x approaches 1 of f of x. We see here as x approaches from below, we hit 1, 2, 3. However, when we take the limit from the other side, we hit 2. It gets closer and closer to 2. Since these don't match, the limit does not exist. So we write does not exist. Okay, and you can also notice there's a jump. Call this a jump here. Okay, the next one, the same thing happens where I graph these two functions, and we want to see what happens with this graph as x approaches 2. So if we're coming from the left side, we hit, 1, 2, 3, 4. And from the right side, we hit 2. Since 4 does not equal 2, the limit does not exist. The next one, we have 3 pieces here. Notice this one right here is just the ordered pair 0, 1. That's just a point. So we don't consider that when we're taking limits. So keep that in mind when you're taking limits. That's just a point. It's not an interval. It's not continuous. So we're going to look at the limit as x approaches 0 from the left and from the right. We follow the continuous function all the way up. It gets closer and closer to 0 without equaling it. And then when we go from the right side, with this x coming from the right, this is the x coming from the left, it gets closer and closer to 0. So our limit is 0. Again, this has nothing to do with it. So you can almost take that out. All right. The next one, we're looking at as x approaches 0 from the left and from the right. So as x approaches from the left, this is your x going that way. As we get closer to the 0, we go to 1. However, when we go from the right, we get negative 1 is our n. Since 1 doesn't equal negative 1, the limits are different. The limit does not exist. Okay, and this one you can see there's going to be a limit. And another way you can tell is I'm drawing this. It's a function. And there's the point where it stops. There's the two pieces. This is your sine function. Sorry again for the bad graph. It's hard to graph on this. And then it continues on up. As we approach, x approaches 0 from the left, it equals 0. And as it approaches from the right, it equals 0. So the limit equals 0. This is supposed to be x. And the last one, we have two graphs. We have e to the x, which is this one. Again, if you graph this separately, I graph these together, that would be open circle. But since this one equals it, a closed circle overrides open circle. If you take your pen and just kind of draw on here, you notice that you don't have to pick your pen up to draw this. Well, we notice as x approaches 0 from the left, we hit 1. And from the left, do that in green, it also approaches 1. So that is our n, so the limit equals 1. And that is all.